we have to see how we can design our well in this borehole. So first of all, we start with implementing a casing here, number 2, and in the production zone of our aquifer, so where we have a section with high hydraulic conductivity, we implement a filter section here with the number 3. And at the end, we have a sump pipe where we can actually collect all sediments which flow into the well. So, of course, what we have to do is also to protect the well for some inflow from the surface, for example. So we have here a concrete revetment. And also we have some ceilings here with the number 7 that we can avoid some hydraulic interaction between aquifer horizons, for example, or also sedimenting exchange in the annulus, or so in the distance from the casing to the borehole wall. So we will fill in this annulus also with some soil material, for example, or with cutting materials. And in the filter section, we have a filter sand or a gravel pack. We will talk about the function of this later on. You see another well design here, some familiar things like filter screen, sump pipe, casing, and also the gravel pack. What we have in the filter section, we have a grout ceiling again here, also a grout ceiling at the top to protect our well and the borehole. And what we see here also is if we pump out the water, of course, you have a drawdown of your static water table. And so the water table is decreasing. What you see here also is some well losses, so well loss effects. This sort of the skin loss. We will talk about this later on a little bit. Of course, you can have different geological formations. So you can drill a well in unconsolidated formations, but also if you have an aquifer which is karstified or fractured, you can have it in a crevassed formation. So the difference is that you put in a filter section in the unconsolidated formations, and in some cases you have an open hole section in some hot rock formations. So you do not need a filter section. The water really goes from the rock directly to your hole, and you have an open hole section. This is a difference of the well design depending on the geological formations. You must also consider how deep you drill your well. So if normally it is recommended that we have a perfect well, so a fully penetrating well, which means that the well reaches the whole section of our aquifer from the top to the bottom. And so the filter section encompasses the whole aquifer thickness. You can have also an imperfect well, which means you just use a part of the aquifer, so you do not drill your well so deep that it reaches the aquifer basis or the next aquitard. So this can have some advantages, like you just save money because you do not have to drill so deep. The reason can be that you do not need so much water for your ground well heat pump, for example. So you need less water. You do not need so much inflow into your well. There are some disadvantages that you change the inflow flow velocity. So then it can be a little bit of high risk of some corrosion effects and whatever. So it's recommended to drill a fully penetrating well, but there are some reasons that you're not doing that. So an imperfect well can be okay, would be better to have a perfect one, especially if the water table changes. So if you have a decrease of your water table, and then maybe because of climate change, and then the water table is not enough anymore that you pump out the needed water, then you have to deepen your well maybe. This doesn't happen if you have a fully penetrated well. So the next point is that we have to look at our well filter. So groundwater streams through the well filter to the pump and into our well. So there are some requirements to a well filter. Of course, it should prevent an inflow of sand into the well interior. It should prevent also some clogging effects, so the filter slots should have the right size. So a maximal open area of screens is of course very good for us, because then a lot of water can enter into the well. But also a homogeneous distribution of the filter slots is recommended, because then you do not have heterogeneity also in flow velocities. This is good also to avoid corrosion, incrustation, and so on. Also, your material, what you use, should be, of course, corrosion stable and incrustation resistant. The stability plays a role. So if you have a large filter slots, of course, maybe the stability of your pipe is not so good. So you have to design that also quite well, but normally it's standardized anyway. So these are some requirements for the well filter. You have to see that also the filter and the water must enter your well and through the filter, though the filter has also some resistance. And this resistance should be possible low, but this leads us also to some so-called skin effects. So what is the skin effect? So it's actually a loss what you have here because of resistance against the inflow of the streaming water into the well. So the water level in your aquifer is maybe a little bit different from the water level in your well, and this is because of these skin effects. So there is a critical filter slot size and a filter inflow velocity. So this must be considered that to avoid rapid well alteration. So if the flow velocity is a lot changing and quite very heterogeneous, and you should minimize also the well skin effects, so inflow losses. There are some recommendations that the screen should be about 50% of the filter pipe, or between 15 and 60%, so not less than 15. And if you have more than 60, actually, then the inflow losses play no role, but that's a theoretical value anyway. You should also think about the length of your filter section. We talk about that a little bit in having a fully penetrating well or an imperfect well. Of course, the filter section should comprise the thickness of the geological layer, which are relevant for the production completely. And if you have inhomogeneous aquifers, the filter section should be set only in the layers where we have a high hydraulic conductivity. It makes no sense to put the filter section in aquitard sections. And if you have an unconfined aquifer, you should consider that the filter section should be set only in the bottom part of the aquifer to avoid that your filter section falls dry, because of the water table is changing and there is a dynamic. So this is not good. Then you change also hydrochemical situations in your well, and this can lead to well alteration. So we talked about the gravel pack in the well design. So what is the function of the gravel pack? You can have natural developed wells. So you have to develop your well and see that you have a very good inflow into your well from your aquifer to your borehole and your filter section. So, but if you have a natural developed well and an open hole well, then actually you just do not need a gravel pack. Normally, a gravel pack is used. So you have the filter section, and around the filter section, you have a specific gravel pack. The gravel pack should hold off fine materials from the aquifer and minimize the skin effects, respectively the inflow losses. So there are specific possibilities of setting such a gravel pack: simple gravel pack, grades multi-pack gravel pack, gravel baskets, and so on. The gravel pack must be also integrated quite very carefully. So you have to see what is the specific gravel pack size, what you what we have to use depending on the grain size of your aquifer. So you should use gravels with the right size that is not going through the slots, and too big gravels actually cannot avoid that fines and can flow into your well. So the gravel pack should be also saved, that it's not breaking, because not actually cracking your filter section and whatever. You have a defined grain size curve. It should be not undersized. It should be almost carbonate free, clean, no iron oxide coating, that you do not have a well alteration caused on your gravel pack. We talked also about the sealing. So the function of the sealing is that we prevent inflow of surface water, and also that we have not an interaction between different hydraulic aquifers. So the design is that we have a selective depth-oriented recondition of single aquitard. So where we have normally an aquitard section, so a clay layer or whatever, we also should look that this is also in our annulus, so in our borehole. So we use here some sealings. Materials can be different. So we can have a cement suspension normally, which we fill in, and then actually it's get hot after time and it's get quite tight, or clay material or clay cement mixture suspensions. Everything is actually used here. So fill-in techniques is you can pour it in or inject by tubes. So the cement suspension is then injected by tubes normally. The clay material is just poured in. And you can also have a double filter, which means to have different sizes of these sealings depending on what is your gravel pack, for example, and if you have a sand filter in other horizons. So between these packs, sand filters or gravel packs and so on, you can have also a filter that these different grain sizes are not mixed. And there are some specific conditions for these filter sections. After you designed your well and your sealing and so on, you have to develop your well. This means there are a little bit disturbance from the drilling process, so that your well is actually not really perfect connected to the reservoir, because you have some smearing or whatever at the borehole wall. So you have to develop it. Normally, the methods are that you inject compressed air with a rod, or you just pump out a lot of water, and then in the first time, a lot of sediment can actually come with this pumped water. So the pump you use should actually be able to pump also a little bit sand fraction. And also what is important for the well development is that you destroy some so-called bridges, what you see here in the pictures, so that the material in the aquifer is actually sorted, so it's that the water can goes in. So what you do is you turn off the pump in constant time steps, or you're changing the pumping and backwashing, that you destroy these bridges, and that the water can actually enter into your well quite very good. So of course, from the well design, there are different other possibilities. So what we talked about is this vertical well, what you see on the left side. So a normal vertical section. And so the water can enter actually in these all from every side, but just on a vertical in this vertical section. Of course, if you have maybe not enough water and not enough aquifer thickness that you can pump out the water you need for your groundwater heat pump, then you can also develop a so-called horizontal well, which you see here on the right side. So there are horizontal sections drilled in a horizontal way, so that you can collect a lot more water, because a lot more water, or you have a lot more ways for the water to enter your well here. So you have some strings here in different directions and can collect the water from a larger area, so it increases the productivity. Okay, that's all from the well design, and yeah, I hope you enjoyed it.